Hello, everybody. Welcome to this session of Geo AI Bytes. My name's Dan, and I'm going to take you through today how anyone, yes, absolutely anyone, can build an AI model, ML model, deep learning model, however you want to call it, to detect objects in geospatial imagery. So, be that satellite, be that drone, be that aerial imagery, anything top down, taken from the view above of the world below. Let's see how anyone can do it. Even me, I'm a marketeer, and no offense to any of my fellow marketeers out there today in the audience or my colleagues, but even I can do it without any data science background. No need to learn how to code, install libraries, use Python, any of that business. And we're going to show you exactly how to do it now. So with that, I'm going to dive straight in to the Pictera platform and show you just how quick and easy it is to create an ML model in minutes. Now, first off, a quick tour of the platform for those of you unfamiliar with it, seeing it for the first time. This is our main dashboard area, and we're split into two distinct areas: our projects, where we gather together all of our imagery, crucial for building a model, and detectors, where we build our detectors to find whatever it is we want, any object, any change. Now, you may hear me saying detector and model. They're kind of interchangeable terms. We like to call them detectors within Pictera because that's what you're doing. You're detecting your custom object or change or anomaly or whatever it may be within the imagery, but you can quite easily call them models as well. So I'm going to dive into a project I have favorited here on the home screen, and we'll see that there are no images within this project. Of course, that's our first starting point. If we want to train our custom model on our object of interest, we need to get imagery first. Now I can either upload my own from local storage, I can import from a URL, but I can also import from an imagery server as well. That's what I'm going to do today. I have a number of them set up already. I can add a new one, be that WMS, XYZ, ArcGIS image service, for example. And in fact, I'm going to use an Esri world base map. And I'm going to search for a specific place. I'm going to search for Madrid. That's where I live. That's where I'm based today. And I'm going to zoom in a little bit. And actually, I'm going to, as an area of interest, my AOI, use my neighborhood. So I live on the west side of the city. I'm not going to tell you exactly where I live. That'd be weird. But I'm going to draw an area of interest around my neighborhood because actually there's something in here that I can train the detector on that's very close to my heart. So I'm going to draw an area around my neighborhood. As such, that'll do. And I'm going to import that area of interest. I'm going to call it my hood. I've got two methods for importing here. I can have a stream, which leads to a faster import. So it's grabbing that image from the remote server and streaming it to Pictera. Or I can choose to download it. So it downloads as a GeoTIFF and then keeps a long-term copy. That's great if you want to use advanced tools, which we're not going to do in this instance. So I'm going to choose streaming. Now, whilst it's preparing that import, I'm going to tell you what it is that I'm building a detector for. And that is paddle pitches. What is paddle? I hear some of you cry. Well, it's a cross between tennis and squash. Really fun game played in doubles, 2 versus 2, in a quite small court, usually enclosed with walls or glass surroundings. If you're having a performance match, for example, really fun game. Now, just in the same way that anyone can build an ML model, as you're seeing me do now, anyone can play paddle. It's a really easy game to pick up, very fun, very enjoyable. I definitely recommend it. But anyway, this is not a session about paddle. This is a session about building a model. Now, this is the area of interest that we've chosen to stream into Pictera. Great, that's what I want. So I'm going to drop into my detector view, and I'm going to train a new detector. Paddle pitches. Keep it private to me. I can share it with the rest of my colleagues here at Pictera if they want to go play paddle. And I'm going to keep it as a count because we're wanting to detect individual objects here rather than say an area of coverage or land use, an example. So I'll keep it as count, And crucially now I need to select my training image. So let's go into my project. Let's add that image that I selected earlier. Now here, of course, you could have multiple areas of interest, which when you're building an accurate detector, you're going to need lots of areas of interest to train the model. But this example, I'm just using one. Now, the great thing about Pictera is that I always get these little handy tooltips to guide me through the experience of building my detector. And it's telling me that I need one training area, one outline per class, essentially one annotation of said object, paddle pitches in this example, and one accuracy area. Now, we'll come on to what that is in a second. But first, let's start building and annotating what it is we want our detector to be able to learn. So let me zoom into this area of the neighborhood that I'm in. And this is a sports center. It has 3 tennis courts here, the blue ones, has 3 paddle pitches, the green ones, and swimming pool and some area around here. Now, we're not interested in those tennis courts. So when we draw our training area around this sports center, we only want to annotate the paddle pitches. So we can draw an outline and we can start to use our drawing tool around that paddle pitch. Done. Now, of course, these are quite uniform shapes. They're quite easy to annotate. So I could go ahead and do the same annotation. But to make it a bit quicker, I can clone the annotation I've already made, click, and there we go. Really important when you're training a detector that you annotate every single example of your object of interest within these training areas. If you don't, you're really going to confuse the model. So yep, in that case, I've done it. And now I'm going to move over the road. And I've got another club over here, very close, that I'm going to draw a training area around. And again, I'm going to start to annotate in this instance, the green paddle pitches. The ones in the middle are, again, tennis courts. We don't want those. And again, I can pick up this annotation that I've made, the polygon, and duplicate it for the additional pitches. Now, you have to be very careful when you're in count mode that you don't overlap these polygons. So you'll see that, for example, if I just move this over here, don't do this. Again, really confuses the model. If in doubt, make your annotations a little bit smaller within the area that you're annotating. Just to zoom in and make sure that, yep, looks good. Okay, so we've now got 2 training areas and we have 7 examples of paddle pitches. Cool. Now I know down here, the kind of south end of my neighborhood, there's 6 more paddle pitches here. Now again, I could draw a training area and annotate them. But actually this time, I'm going to do something a little bit different. I'm going to draw an accuracy area. And within the accuracy area, I'm also going to annotate those paddle pitches. But in this example, when the model starts to train, it won't use annotations to train from. It will only use the ones in the training areas. What it will do here instead is that when it's trained, that first iteration, it will look in the accuracy area and it will start to see if it can detect any paddle pitches. It will then compare its detections it's made against the annotations that I'm making here to give you an accuracy score. So again, we need to draw outlines. So let's go ahead and draw an outline around that first pitch. And again, just as we did previously, we could clone this annotation across the other 5. But let's, for the sake of argument, say that we're annotating something a bit more complex, that would take us a little while to draw a polygon around. Well, this is where we have something called the AI magic wand. And I'm going to initialize it now. It's based on Meta AI's segment anything model. It enables us just to simply click, and you'll see that it automatically annotates what it is we're interested in. Pretty cool, huh? All right, so now we have 2 training areas, 1 accuracy area. We're ready to train, right? So we could go ahead and train this model now, and off it would go and figure out what a paddle pitch looks like so we can then detect its scale. But one of the things we want to do perhaps after that first training and when we're iterating to make the model more accurate is to make sure that we let the model know what it is we're not interested in. So remember, in this case, we're not interested in tennis courts. And if I zoom into this section of Casa de Campo, this huge park on the west side of Madrid, I can see a lot of tennis pitches here. I don't want these. So I'm going to draw a training area around these and not annotate anything. So now the model knows that this is not something that we're interested in. Now, typically, best practice wise, you would do this sort of action after your first training. I'm just doing it now to show you how that works in reality. Okay, so let's go ahead and train. Click on the big green inviting button at the top, and off it goes. Now, whilst it's training, I just wanted to share with you a few other examples of the sorts of things that you can build detectors for within the platform. Now, this is an image, satellite image of Heathrow Airport in the west of London. And we've built a multi-class detector here so that we can detect airplanes, buses, cars, trucks, and you can keep going. So for example, we see that Concorde down at the bottom here hasn't been detected. Well, we could simply add another class and train it on what Concorde looks like as opposed to these more typical jumbo jets. Now, this is an area of rainforest in Sumatra. And for this one, we could build a detector to detect every single tree. But in this example, what we've done actually is we've built a detector for just the palm trees. So let's zoom out and we can see the examples, and we can zoom in as well. You can see the differences in the palm trees to the rest of the vegetation. In this example, we have 4 different types of crops. So we've built a detector to pick up the different species of crops in this scenario. Now, what's cool is we can take this a step further and actually look at land usage as well. So we can say, okay, well, how many hectares does each of these crop types take up within my farm? Here we have a city, a town view. I believe this is in the UK. I think they're driving on the left, right? Yeah. And we've built a detector for this case for cars, simply cars. But if we wanted to, we could detect individual models and make of cars, as long as we train the detector on enough examples of such models and makes. Here we have a city in the US. This is Bellingham. And we've built a building detector. So this is now telling us where all the buildings are. But again, you can take it a step further. You can detect solar panels on the roofs within here. You can detect pools in the backyards. Now, one thing we like to talk about a lot is that pre-trained models often fail because people apply models that have been trained on certain scenarios in different areas and different contexts. So, as an example, let's fly across to Cameroon in Africa. So the building type is obviously quite different in Cameroon. If we use that detector that we had for Bellingham here, wouldn't work quite so well. Now, actually, next week's GeoAI Byte session is all around why pre-trained models fail and the importance of human in the loop. So don't miss that one because we're going to be talking in detail about why custom models and the capability you can do them here really do win over pre-trained models. You can see the model here. This is a custom model for the buildings in Cameroon. Now, this is a nice example. Can you tell what's going on in this picture? Maybe if I zoom in a little bit. Well, this is a seal and sea lion detector. So you can see that it's individually annotated and outlined and detected all of the seals and sea lions. Great for conservation efforts, biodiversity. And then talking about doing things at scale, this is the whole country of Denmark. Now, what's going on here? Well, the project here by Sedges was to detect slurry tanks across the whole country because they wanted to estimate the ammonia emissions of the whole country. Now, this project, in less than 2 weeks' time, and actually very few annotations, like 50, 60 annotations were made to train the model here, went out and then detected over 26,000 tanks across the entire country. Let's zoom into just one example. Now, there were different types of tanks, covered and open tanks, so there were sort of some training that needed to be done in order to detect all examples. But you can see that the model was built from scratch in less than 2 weeks to detect everything at a country scale. Okay, let's check in on our little detector that didn't take 2 weeks. It took 12 minutes. Let's have a look. Okay, great. So we're looking at about just over 90% accuracy based upon the accuracy area and the annotations that we gave the model. So again, it's a relative figure, but straight out, it's looking very good. It's managed to detect 5 out of those 6 paddle pitches in that accuracy area. So now the next stage will be to iterate. If we're happy with that accuracy, we can go ahead and apply that detector at scale to the whole city, to the whole country, if we wanted to. But of course, we can then iterate. We can import more training images. We can annotate more examples within more training areas. And actually, we've got some great features built into the platform that enable us to get some insights as to where we should focus our future efforts. But again, that's for a future session. So all that remains now is to open the floor for any questions that anyone may have. Thank you so much for your attention, and we'll take any questions. Okay, let's see what we've got here. So a few have come through via the various networks that we're streaming to right now. So one has come through from LinkedIn. The question is, could you build a detector on individual Nadir drone photos? So rather than an orthomosaic geotiff. Great question. So to answer that, ideally, all uploaded images to the platform should be geo-referenced 8-bit RGBA geotiffs. Other types of images are supported, so PNG, JPEG, multispectral, single band, but these will have to be normalized first in order to be displayed. And relevant information could be degraded, could be lost within that process. Now, in terms of specific raw drone images, the best way would be to use a photogrammetry software, and you can produce an ortho photo from those images, i.e. stitching, and then upload said ortho. Question coming through from Facebook. Thank you, Alexander. Question around making a recording of this video available. So this should be available straight after this session has finished. So it should be available for on-demand viewing via YouTube, via Facebook, via X, and via LinkedIn. Okay. Just seeing if we have any more. Nope, not seeing any more coming through at this time. But if you do have any questions for myself or for the team, do pop them into the comments of this video, and we'll get back to you in the future. We've got one coming in now, another one from Alexander. Thank you, Alexander. So yes, Alexander's asking, can I use images from Google Earth Pro or the other recommended sources? So the beauty of the platform is that we are image provider agnostic. You can get your images, satellite, drone, aerial, whatever it may be, from any provider, open source providers, free providers, paid providers, whatever they may be. So they're all supported. And the crucial step is that as long as you can see what it is you're building a detector for within that image, then you can annotate it, you can build that detector to then go out and detect at a larger scale. So that's the crucial step. You have to make sure that the resolution of the image is sufficient that you can see that visually and you can annotate it and start to build your own custom model. Now the question is coming in. Great. So, Power, thank you. So, can it detect farm boundaries? Yes, certainly. Again, with that previous kind of caveat, as long as you can see it, as long as you can annotate said boundary, then yes, the platform will be able to detect farm boundaries. Okay, well, with that, that's the quick Geo AI Bytes session over for today. A reminder to join next week when we'll be talking about pre-trained models. I did want to use why pre-trained models suck, but that was apparently a bit too controversial. But now I said it, it's out there. So I look forward to seeing you all, same time, same place next week. Thanks everyone for attending. Bye for now.